In the previous slides, I've always made my acid and my base react with water, because water is not a particularly good base or a particularly good acid, which means that it actually can react with quite easily with both acids and bases. But you don't have to use water. You can make an acid, any acid and any base, to react together. And we call that a neutralization reaction. And what you produce when you make an acid react with a base is salt and water. And you notice that I've used the word salt in inverted commas, and I will explore that in a second. So in the first equation, I've had the reaction with words, and in the second equation, I'm giving you some idea of how this reaction might look like if I used a generic acid, AH, and a generic base, BOH. So I will make a salt, Ba, with the anions that, no hydrogen and no oxygen from the acid and the base, and I will liberate, in this case, 1 molecule of water. I call it salt because it really could, the word salt comes from one of the most common ways in neutralization reactions ever performed, which is when you form sodium chloride, which is table salt. So by expansion, any product that you form from a neutralization reaction is called salt. This salt is an ionic compound and is made of a cation and an anion. The cation can be either a metal or it could be a polyatomic ion. So that is a group of atoms that are bonded by covalent bonds, but that as a whole have a positive charge. So as a whole, they behave as an ion. And again, the anion can be or a polyatomic ion, so a group of atoms working together bonded with covalent bonds, but that have, in this case, a negative charge, or a non-metal. The only polyatomic ion it can be is the hydroxide anion, the OH minus. But any other could be part of your salt. So I'm going to ask you to stop the video now and have a go at giving me the balance equations for these three reactions. Stop the video now, please. So how to do these exercises? Well, the first one hopefully is the most straightforward one because it's a very, very famous reaction, the reaction of sodium hydroxide and hydrochloric acid. You form the salt NaCl, sodium chloride, table salt, and you produce 1 molecule of water in the reaction. The second one, in a similar fashion, you have the calcium hydroxide, the calcium ion reacts with the, in this case, it's an example of polyatomic anion, the nitrate anion. You just need to be careful of how to pair them. Calcium, if you see here, needs 2 OHs, 2 OH minus to compensate them. That means that your calcium is actually calcium with 2 positive charges. And the nitrate anion, NO3, only has one negative charge. So you will need 2 nitrate groups to compensate that calcium because it has 2 positive charges. So the compound you make is calcium nitrate, which has this formula, 2 nitrate groups. And again, you make water. But in this case, you cannot stop right here. You need to balance the equation completely. You need 2 nitrate groups, so they both are going to come from here from the nitric acid. So that means you need 2 molecules of nitric acid for each molecule of calcium hydroxide. And that means that when you look at how many hydrogens you've got and how many oxygens you've got, then you end up with 2 hydrogens from the nitric acid and 2 hydrogens that come from the calcium hydroxide. That's 4 hydrogens. So you need to put a 2 here. And these 2 also account for these 2 oxygens. They are the only ones that were not balanced. So that's how it looked like. You will make calcium nitrate, you liberate 2 molecules of water, and the reaction would be 1 of calcium hydroxide. The ratio would be 1 of calcium hydroxide react with 2 of nitric acid. The final one is might not look as it fits really well with the whole salt and water, because you're not going to see the water, even if it's implicit that it's there. And that is reaction between ammonia and hydrochloric acid. Well, ammonia is, and I just wanted to put it here just to kind of say, show that, yes, you have some sort of generic, this is how the equation looks like, but then you have slight exceptions that do not fit beautifully to this generic equation I've drawn at the beginning of this slide. Ammonia is a base, hydrochloric acid is an acid. What do bases do? They accept hydrogen ions. What do acids do? Well, they donate hydrogen ions. So that means your ammonia is going to accept one hydrogen ion from the hydrochloric acid. How do you end up with? Well, you have NH4, 3 hydrogens from the ammonia plus 1 that has gain, and plus, because it's accepting a hydrogen plus, a hydrogen without electrons. The electrons are left behind with the chlorine, which becomes a chloride anion. All this would be in aqueous form, and that's where the water is. It's just implicit. And what you are making is this compound NH4Cl, and this is called ammonium chloride. So this is, for example, this is an example of a polyatomic ion working as a cation, while in the previous case the nitrate anion was an example of polyatomic ion acting as an anion.